Okay, so let's get into it. We all hear the term machine learning thrown around constantly.
All the time.
But today, let's move past just the definition. We want to really explore the core mechanism. How do machines actually learn from the data we're all feeding them?
All right.
Because, I mean, this is the engine behind so much of our modern tech. Everything from your smartphone to finance and even healthcare.
And what's really fascinating is that a machine's idea of learning is, well, it's not like ours.
Not at all.
No, it isn't thinking or reasoning. It's purely mathematical. It learns by finding patterns, statistical patterns, in just massive, massive amounts of data.
So let's walk through that process. Generally, it starts with what we call supervised learning.
Yeah.
This is probably the most common type.
Mm-hmm.
And it all relies on having labeled data. Basically, data where we've already given the machine the correct answers to learn from. It's like a student with a study guide.
And that process really has a few key stages. First, you have to collect and, crucially, clean the data.
Oh, that's a huge one.
It's everything. I mean, data quality completely dictates how smart your model will be. Garbage in, garbage out. It's that simple.
Exactly. So after the data is clean, then you actually train the model. And if we're, say, trying to predict house prices, the data isn't just a list of addresses.
No, it's broken down.
Right. It's broken down into what we call features. So things like square footage, number of bedrooms, the zip code. Those are the details the machine actually uses to calculate a price.
And once it's trained on that data, you have to test it. You give it new data it's never seen to see how accurate it is. And this is where the big risk with supervised learning comes in.
Overfitting.
Overfitting, yeah. If the model learns the training data too well, it just memorizes the noise instead of the actual signal. Its predictions just fall apart in the real world.
So supervised learning is powerful, but what happens when you don't have those neat, hand-labeled correct answers? Which I imagine is pretty often.
All the time. Labeling data is expensive and slow. And that's where unsupervised learning comes in. With unsupervised learning, you just throw all the labels out, you give the machine a data set, and its only job is to find hidden structures or groups on its own.
So it's more like self-discovery for the machine.
Exactly. And the applications for this are huge. You're not predicting a known answer, you're finding similarities.
Like grouping customers for targeted marketing.
Perfect example. Or finding unusual bank transactions to flag for potential fraud. It excels at spotting anomalies.
Okay, but what if you have a little bit of labeled data, but a whole mountain of unlabeled data? Is there a middle ground?
There is, and it's called semi-supervised learning. It's a hybrid. You use that small, trusted set of labeled data to get the model started.
To set the basic rules.
Right, to set the rules.
Yeah.
And then you let it loose on the massive unlabeled data set using unsupervised techniques. It makes the whole process way more efficient.
And that brings us to the last one, reinforcement learning. This one feels a bit different.
It's very different. It's all about trial and error. Think of it like training a pet. The machine takes an action, and then it gets feedback. A reward for a good action, a penalty for a bad one. And over millions of iterations, it learns the strategy that gets the most reward.
And we see this in things like game-playing AI, right?
Yeah.
For chess or Go.
That's the classic example. But also in robotics and self-driving cars, the car is constantly making decisions to maximize a reward, whether that's safety or speed or efficiency.
So pulling this all together, understanding these four methods is really key. This is how ML drives all the automation and personalization we see everywhere. It's not the future anymore. It's just the present.
It really is. And since we now get the basics of how machines are trained through labels or self-discovery or rewards, here's the critical thought to take away. Think about how these fundamental ideas, these building blocks, are the foundation for much more advanced topics. How do they create the layers in deep learning or enable the really complex multi-step actions you see in agentic AI? That's where all of this is heading next.